Hi all, in this video we are going to talk about the derivative of inverse functions. So let's say we have a differentiable function f and f inverse be its inverse. Then the derivative of f inverse can be found by just using implicit differentiation. So let's say f inverse is equal to y, f inverse of x is equal to y. So if you take f of both sides of the first equation, you are going to have f of y equals f of f inverse of x, but what will happen with f of f inverse? First, x will be mapped to y by f inverse, and then f will map y back to x. So we will get x again. So f of y equals x. And then here, we take the derivative of both sides and use implicit differentiation technique here. So when we take the derivative of both sides, what's going to happen? Well, the left-hand side will be, it's actually a function. Y is also a function. So there is actually chain rule here. F prime of y times y prime. And then on the right side, derivative of x is 1. So we have the second equation here. And then if we divide both sides by f prime of y, then that's y prime. But we want to write an expression in x. So instead of y, what do we write? Well, y was f inverse of x. So instead of y, we just write that. And then we get the derivative of f inverse of x, which is 1 over f prime of f inverse of x, which was written instead of y. So anyway, using this method, we can find derivative of inverses of some functions. And this is one of the very important ones, derivative of ln of x. This is equal to 1 over x. So how do we do? We just do in the same way we have just talked about. So we just have first y equals ln of x, and then the inverse of ln is e to the x exponential function. So we write both sides of the equation as powers of exponential function. Then we have e to the y equals e to the ln x. But e to the ln x is x because exponential and ln functions are inverses, so it's just going to be x. Then we have e to the y equals x. Then take the derivative of both sides and apply chain rule. So derivative of e to the y will be e to the y again times derivative of the power, which is y prime or dy over dx equals 1. Divide both sides by e to the y. So y prime is equal to 1 over e to the y. But remember, e to the y is equal to x. Remember, like we have e to the y equals x. So if we write that back, dy over dx is equal to 1 over x. So that's the derivative of natural log of x function. This is a very important function, and it has to be used in so many computations in the integral differential calculus, also in differential equations. So we should know this derivative. The second derivative is arc sine of x. That's equal to 1 over square root of 1 minus x squared. So here, arc sine and sine are inverse functions. Okay, so arc sine is sine inverse anyway. So if we call arc sine as y, so y equals arc sine of x, and then take the sine of both sides, sine of y will be just x. Then take the derivative of both sides. Derivative of sine of y will be cosine of y times y prime, which is just chain rule, and derivative of x is 1. Divide both sides by cosine of y, then y prime is equal to 1 over cosine y. Now, we have the equation sine of y equals x. So from this equation, we can actually obtain a right triangle. And from that right triangle, we can find an expression for cosine in terms of x. Cosine of y can be written in terms of x. So how do we get this equation? If sine of y is equal to x, what is sine? Sine is the opposite side to y divided by hypotenuse on a right triangle when the angle is y. And x can be written as x over 1. So draw a right triangle, put the angle y. So if sine of y, which is opposite side to y, is x and hypotenuse is 1, then write 1 for the hypotenuse and write x for the opposite side to the y angle. And then from the Pythagorean theorem, we can find the third side which will be square root of 1 minus x squared, which is square root of hypotenuse squared minus the other side squared, which is 1 minus x squared. Okay. Then from this right triangle, we can write cosine of y, which is, cosine is adjacent side to y over hypotenuse. So square root of 1 minus x squared over 1, which is square root of 1 minus x squared. So put this into the derivative formula here. Y prime will be 1 over square root of 1 minus x squared, and that was the answer of our question. Now, third example, let's say derivative of arctangent is equal to 1 over 1 plus x squared. So again, arctangent and tangent are inverse functions. So we take tangent of both sides of the first equation, like y equals arctangent of x. So that gives tangent of y equals x equation. And then take the derivative of both sides with respect to x. For the left-hand side, again, use the chain rule. Derivative of tangent is secant squared. So we have secant square of y times y prime equals 1. And then divide both sides by secant square of y. Then y prime is equal to 1 over secant square of y. So we had an equation for tangent of y, and that was equal to x. Again, that gives a right triangle. So x can be written as x over 1, and tangent is actually opposite side to y, opposite side to the y, angle y, over adjacent side to the angle y. So opposite side can be written as x, adjacent side can be written as 1, if you draw the right triangle. Then the hypotenuse can be found by the Pythagorean theorem, which is square root of 1 squared plus x squared, which is this length here. Now, what do we need? We need secant of y to simplify the derivative formula we have. Secant of y, remember, is 1 over cosine of y. What is cosine? Adjacent to y over hypotenuse. So put that for that cosine y term. And then cosine of y from the right triangle is what? Adjacent over hypotenuse. So 1 over square root of 1 plus x squared. But that's in the denominator. So flip this denominator and multiply. Then secant of y is square root of 1 plus x squared. But our formula was y prime equals 1 over secant squared. So take the square of this term. Y prime will be equal to 1 over 1 plus x squared. And that's the result. Now, similarly, the derivative of the other trigonometric functions can be found in the same way, okay? So you can try doing them. It's just going to be the repetition of what we have done. But the table of derivatives of inverse trigonometric functions is can be written like this. Derivative of arc sine is, we have found it like 1 over square root of 1 minus x squared. For derivative of arc cosine, it's the same function, only negatively, like minus 1 over square root of 1 minus x squared. Derivative of arctangent, we have found it 1 over 1 plus x squared. Derivative of arc cotangent is the same function, only negatively, so minus 1 over 1 plus x squared. And derivative of arc secant is 1 over x times square root of x squared minus 1. And arc cosecant, derivative of arc cosecant is minus of the same function. And these formulas will be necessary, especially when we are talking about integrals. So it may be important to remember these functions. Now, also, finally, let's talk about the chain rules for these functions we have found. For instance, chain rule for ln of x. Derivative of ln of f of x is 1 over f times f prime. So 1 over whatever inside of ln times f prime. So for instance, if we have ln of x squared plus 1, then the derivative is 1 over x squared plus 1 times derivative of x squared plus 1, which is 2x over x squared plus 1. If we have ln of sine of x, then the derivative is 1 over sine times derivative of sine. Derivative of sine is cosine, so cosine over sine, which is cotangent. And chain rule for inverse trigonometric functions are, if we have arcsin of f, then the derivative is 1 over square root of 1 minus f squared times f prime. And derivative of arctangent f is 1 over 1 plus f squared times f prime. Derivative of arcscant of f is 1 over f times square root of f squared minus 1 times f prime. And examples for the derivative of chain rule for arc trigonometric functions. So arc sine of e to the x, let's say, the derivative will be 1 over square root of 1 minus e to the x squared times derivative of e to the x. So e to the x squared is e to the 2x. We just multiply 2 and x, so we get e to the 2x, and derivative of e to the x is e to the x again. For the second one, derivative of arctangent x squared. Well, that's equal to 1 over 1 plus x squared times derivative of x squared. Derivative of x squared is 2x. X squared is we multiply 2 and 2, 2 by 2, which is x to the 4. And then derivative of arcsecant of 2x, well, that's 1 over 2x times square root of 2x squared minus 1 times derivative of 2x, which gives, after the cancellations of 2's, we have 1 over x times square root of 4x squared minus 1.